My name is Gidske, and I'm working at the geography department at University of Bergen. So I use this course as an opportunity to just learn a lot of new things and test out some stuff in an area I've been working before. So yeah, and I should say that it has been really very great course. So thank you to everybody who arranged it. Yeah, so I've been working in arid environments for some time, and I'm really curious about the vegetation and the distribution of the vegetation, and also how people are affecting, so like removal of vegetation. And I was in this project, I just wanted to see how the topographic and hydrological parameters are influencing the vegetation, because then afterwards it would be able to maybe say something about where you predict vegetation, but you don't have vegetation. Could be places where it has been affected by humans, for example. So, but I haven't done the last part. I just been playing with the data. So this is what it looks like, and it's a really dry area. So it's in Sudan, along the Red Sea coast. So the Red Sea is here. And if you zoom in, you can still see that there are vegetation in the wadis. So it's really the water that is, of course, the most important factor, but I wanted to see how, so I have not included precipitation or anything like that. I just wanted to see how the landscape itself affects it. But you can also, maybe it's not so clear from this image, but you also have vegetation in the mountain slopes. So it's not only where you collect the water. So, so I made this overview of what I did. So I used the Landsat data set, the GLAD ARD. So I just downloaded for 1 year, but that was more practical reasons because it was quite slow when I downloaded. So I had 23 images for 1 year. So I calculated vegetation index, and I did this in GDAL Calc. So there was a lot of clouds in some of the images. So I masked the clouds using PK tools. Then I did some stacking of all the images to estimate different statisticals, so like the mean vegetation index for a year and some different things. So I used the mean as my variable. And then I extracted this statistics using PyGeo. So I wanted to try the package because I thought it looked really cool. So, but that took some time to figure out. And then based on this vegetation index that I use called SAVI, it's a soil adjusted vegetation index. So it's more useful in arid environments because there's so much background, very bright background that influence the NDVI, for example. So, so I classified this one into different ranges according to the histogram, just to get different classes. I could distribute my random points that I was going to extract values for within each of the ranges. I'm not sure if I did it in the best way, but at least I wanted to be sure that I had points in all the different classes of the vegetation index. So I used the PK tool, PK extract EMG to get the points. And then I downloaded the SRTM, the 30-meter elevation model, and I used GRASS to calculate different statistics or different variables, so hydrological and topographical, and some distances around the streams, for example, and also the stream junctions, because I have seen that in some places, at least in this arid environment, if you have several streams joining, it's probably higher probability that it rains in either of the subcatchments, and this area will reach or have more water than maybe just along the stream itself. So yeah, so then I did the same type of stacking in PyGeo to extract for the random points, and then I cleaned and merged the tables, checked some statistics, and finally yesterday, yes, I reached the stage of trying to do some modeling, because all this preparation of the data set was really not exactly painful, but it gave a lot of errors that I had to use some time to find out. Yeah, okay, so that's my process. So yeah, so I used grass for the first time in this way. So I also had some problems of installing the add-on because I didn't, the link in my version of grass wasn't updated to the new storages of the add-ons and so on. So yeah, but I got help and found out. So yeah, so this downloading of the Landsat images is pretty much what you showed us in one of the tutorials. So and as you can see, I'm not that good in Markdown, so I have not been able to exclude all these things. So then I calculate SAVI. So this is the formula. And then I use the band 8 to mask out the everything that was not of interest. So I just kept this 1s and 2s, I guess. Land and water, clear sky. So there was also some problems with striping in these images. So that was also masked away. It's a sensor calibration issue. So
Sensor failure.
yeah. So this is the mask now, the white for this specific image. So after masking them, I stacked them, and since I calculated the mean, in the end I didn't have no data for my small area actually. So yeah. So
now you're going to analyze the white pixels, right?
No, not the white, the other ones where I have data, because the white ones are the ones where you have no data or cloudy data.
Okay. Yeah. How do you guys make up these stripes again?
Because it's marked in this table, so the here, so it's these stripes and out of the image. So I just kept the zeros and the 1 and 2s. Yeah. Okay.
Because if you just drop, you eliminate the piece of the associated with stripes.
Yeah.
That's mean that it will actually swap out some data. So for example, these stripes are pretty thin, right? So if you use like Gaussian blur in your data, you could just extrapolate.
Yeah, probably. But since I was having all the 23 images through the year and I calculated the mean, then I got rid of the problem.
Okay.
So, okay. So, yes. Okay. So this is example of the histogram. So the vegetation index is really low in the area, but it's because you have quite little vegetation within each pixel, so you don't really get the very high values. But it's up to like 0. Yeah. It's the 0.6, but it's only 2 pixels. But anyway, yeah. So then I use the PyGeo to stack the images, and yeah. So I think the thing I found out was that I first added like one of the images, and then there was this loop to add the images, and then in the end I removed the first one because to create the gym I had to add one image, and then when I added all the other with just the LS listing, I ended up with 2 of the same images in my stack, so I just removed it in the end. So it's probably a better way to do this. So this is the, and here you can specify the no data. So the when you calculate the mean, it automatically excludes the no data. So I calculate some different types, but I ended up using the mean. So yeah, so this is just one of the images, what it looks like. And so the most of the vegetation is either in the wadis, you can see it some places, and then you have this very special mountain area. So it's kind of mist influence. So you have a lot of vegetation here. So that will, as you will see in the end, it influenced my results. because elevation comes out as a really important variable. But if I expanded my area, it would look different. Yeah, so these are the images that I calculated, and I used the mean. So this was my yeah, so I think I'll just go with this. Yeah, so then I used grass, as many of you did, to calculate some topographical and hydrological variables. Yeah. Already people explained this part, so I don't think I should spend so much time, but I used the R slope aspect tool, and I just extracted everything from that tool. And then I used the R watershed and R stream extract to extract some other layers. And then from the R stream, you can also produce the vector layer, and it has all the junctions. So I extracted the junctions, and then I calculated the distance around the junctions, and I also calculated the distance around the streams itself. Because the closer you are to the stream, the more water influenced it will be. So that's basically what I did in grass. I also used grass to recode my vegetation index according to the histogram. And then I used that together with the image itself to create the random points. Okay, so this is probably okay. So I think I'll just go to the modeling part. So this in the end, when I had extracted both from my SAVI index and all the topographical and hydrological parameters, I got this two table that I was combining and cleaning, and I dropped some of the columns to get what I wanted. And since I'm quite new to Python, this also took some time to even the most easiest things. Yeah, so I had 74,000 random points, and I have like 19 variables. So these are my so aspect, and this is the topographical parameters, and then it's the streams and distance from streams and so on. So I made the predictors table, and I used the code we got, and I extracted divided into the training and the test data set. And let's see, I had some null, or some none values that I had to get rid of. And then I looked at for some of the variables that I found out later was important. I made this scatter diagrams. And one of the, actually the basin, which is here, turns out to be really, really important. And that's just the numbering of the basins. So I think the lack of the values here is because I calculated the basins on a bigger dam, and then I extracted just for a small area. So I think that's why some of the middle integers are lacking.
But this one is basin ID.
It's basin ID.
So basin ID is just a categorical value. So you cannot really use it as a continuous.
No, but I asked about it yesterday, and we thought that in random forest you don't need to.
No. He is going to accept. But you need to declare that it's a categorical variable.
No, that's. We looked into it.
I don't know. But but he needs to know that it's a categorical variable because it's number. He doesn't know that.
No, it's a classifier, so like it's not gonna predict.
No,
No,
as
it's a
predictor,
regressor
as
I
a
used.
predictor. You can use as a predictor a
Oh, so
category.
that's a feature, doctor.
That's a feature.
Ah, but we're trying to predict that.
No.
Okay, my bad, sorry.
Okay.
So,
Okay.
frankly speaking, you can use as a predictor, but you need to declare. that
Yeah,
it's
so
a-
that's what
it's
I
a
wanted
category.
to find out yesterday, but yeah, okay.
Okay,
So-
okay, misunderstanding. But
Misunderstanding.
And of course, you can, if there's categorical, you cannot do it. This kind of category.
No.
Because it's useless, it's meaningful.
Yeah.
Okay, no problem.
Okay, so anyway, but yeah, okay. Yeah, so this is just some of the scatter plots. Yeah, so that's the histogram and yeah, okay, so then finally here's the random forest. So first I did it with the default parameters. And then I tried to do some adjustments further down in the notebook, and then I updated my values here. So, but then I probably should remove the basin
Okay.
or yeah, I don't know. But yeah, so this actually, this was the Pearson R values, but I also get a really high out of bag. So that means that this one should be low. Or? Oh, it's the opposite of the, okay, so this is not so bad.
No, it's not so.
Okay, so this is what it looks like. So what, I mean, the really highest NDVIs are underestimated, but as you saw from the histogram, I don't have so many values in the high range. So, yeah, so this is what it looks like, and the basin is actually turning out really important. And when I was, yeah, but I did, yeah, I don't know how it works in Python, so, but in R, I certainly would put it as factor. Yeah.
He doesn't know that it's a category. If he's going to 1 to 10, you have 10 categories. Yeah. From 1 to 10. How he knows that it's a categorical?
For instance, in Python, you're not even able to be categorical.
Yeah, but there should be a way. Because
They're indexes. That's it.
no, I don't think so. Because he cannot say, Antonio, he cannot say bigger than 5. Random forest works in threshold. Okay? So if you say bigger than 5, what does it mean if they are category A, B, C, D, F, G?
No, you have an indicator that's association with that.
Yeah.
Yeah, but you have to say that are classes in some way or
You don't have to. Random forest is also kind of type of thing.
no, for a simple reason, because if it's categorical, he would say equal to. If it's equal to A, do this. If not, do that one. It doesn't use a thresholding, but use a pi. So probably in Python, you have, rather than say from 1 to 10, you have to say A, B, C, D, F, G, whatever. And then he will understand it.
That's what index. That's what I'm saying.
To an index, perfect, perfect. Is another way of saying, but you need to convert in index. Okay. So this is-
And why do you think that you cannot do equal to 1, 2, 3? You can't do that.
Yeah, but I want to say the algorithm need to know in some way.
The algorithm is gonna learn that. That's what it's machine learning for.
Okay.
But he need to know that it's a
You
class.
don't have to know.
Okay, but I think, I mean, I would really like to know whether this is makes sense or not. But for me, it could make sense in a way because the basins are quite small, so it would be like a indicator of the very local water conditions in that area. And in my mountainous area, I guess, yeah, where it's really much vegetation, many of them are in the same category. So maybe that's why it turns out so important. I don't know.
I think it's just a matter of luck.
Okay. But anyway, so
Random forest classifier by is constructor automatically into categorical variables.
Yes, but he has to know. That is
Now
the
you
point.
automatically, so like you have to determine it's no longer automatic, right?
Impossible, because he doesn't know.
It's Python, bro. It's not
Yeah.
okay.
Impossible.
Okay, so maybe basin is important. I made a basin like with a 2000 pixel threshold, so they are quite small. It's 30-meter resolution, so it's quite many small basins. And then elevation, as I mentioned, because I have this part of my area where you have one specific mountainous area that is really a lot of vegetation. I think that's what's make it so important. And also this is the stream distance from the junctions, which also makes sense, at least for me. Yeah, and then it's some of the other variables. Yeah, so this didn't turn out very nice. I should have cropped the images so you really saw, but in this area there are many small basins inside, so you can't really see it. So that's the elevation, and this is the distance from the junctions in the streams. So I tried to do some tuning. So this is where I had the estimators. Yeah, that's not what I did actually. So I did from 40 to 100. And it turns out like this.
Okay,
But I was
so-
wondering, because I had to do this, I'm not sure if this is correct, because I had to implement it without internet, so I couldn't really find the function I was looking for. So I tried to copy it from the other and it worked. So yeah.
So what did this plot is telling?
So this is, it tells me that it's actually quite stable already after 50. So
this is number of trees
Yeah.
in the forest, okay?
Yeah.
So as you can see, as soon as you go.
So
Yeah.
I chose 80 for my final.
It's more or less stable.
Yeah. And then I tried to do it for the see maximum depth. It didn't have any influence. I just did it for 3 different depths. So it didn't make any difference. And I also did it for minimum samples of leaves. And that gave this plot. So I don't know, should I go for a value where these are closer, or should I just go for a value where I get the highest?
Ideally, if you see that that's training set, that's validation set, right?
Yeah.
Yeah, so if you have a performance that's much better for a training set, that would indicate that you have bigger overfitting. But you see that you also have higher performance for the test set, so that's no longer, that's not overfitting, right? So like, yeah, just use whatever is better. You should usually this analysis of like what's the optimal parameter in this case. But if you see that there is a divergence between them, but going the opposite direction. So in this case, you're fine.
So I could use something very low, or
Yeah, 20 sounds like the best.
okay. Yeah. So what was this? Was last one I tried was max features.
Okay. That is the number of variable permutating in each
Yeah.
single node.
So that looks like that. So yeah.
Okay.
I think that's my end. Yeah, but I really want to know whether this basin stuff is making sense or not, code-wise. But we can maybe talk about it in the break.
Nowhere so far that I've seen that you have to declare that the variable is nothing more.
Okay, okay, I don't listen. We didn't match with it, no? We didn't match with it. You are the algorithm, I try this number. Now we ask, is a categorical or is a complete?
Integer. Integers are discrete. It's an integer.
So, is a, no, reply, is a categorical or is a complete?
Could be both. What's the difference?
He needs to know which one is which.
Random forest in Python doesn't need to know that. That's what I'm saying.
Okay, so if it's categorical,
Yeah.
you can say that 2 is double than 4.
We're gonna learn that, bro. If that information matters, random forest is gonna learn that. Let's do the opposite. Show to me that in random forest there is even a few vertical.
Because if it's categorical, if random forest know that this column is categorical, now I don't know how to say Python properly. I need to say A, B, C, D.
No, Python doesn't accept this kind of thing. It has to be integer.
Okay, so if it's integer, it's going to be considered categorical or continuous.
Random forest is gonna learn that. If that information matters.
Because when it's
There is
categorical,
no way to pass this kind of
when it's categorical, random forest is going to give you equal to. If 3 is equal, if the value is equal to 3, do this. If not, do that. When it's continuous, you're going to make a pressure bigger than. So can you do bigger than 3?
Aren't those relationships learned?
Sorry?
Aren't those relationships learned? So for example, if equal to 3 is meaningful, isn't that something random forest is gonna learn? Random forest is gonna learn. Isn't that the whole purpose of random forest? It's to learn how to assign.
Okay, in R you have to declare that it's categorical.
Again, there is no way to pass this up to random forest to Python. Like random forest doesn't accept inputs like, oh, these variables category.
Okay, in R it is. In R it is. So I don't know. I don't know how they implement this in Python because, frankly speaking, if I give you a list, you cannot tell me 3 is double than 6. Can you tell me in advance yes or no? No.
No, and you're gonna learn that.
Ah,
That's the whole
ah.
purpose. But we use a lot of data. That's the whole purpose of machine learning. That's
But
the
if-
whole goal. of
But
machine
if he
learning.
doesn't know, tell me how you can know by you this one is categorical complete.
If you give a lot of data, we're gonna learn.
Compared to something else, maybe. Compared to
Of course,
something.
but we have labels. So that's what random forest is trying to. I'm gonna use these labels to learn this relationship.
Okay, maybe with the labels. Okay, maybe.
Now, maybe with the labels, random forest needs labels. Like it's a necessity.
Okay, okay. I don't know if
Ah.
Python. No, okay, I tell you, I don't know if Python, but in R you have to declare. So probably there is a reason.
Because R is immediate. That's it.
Because,
R has 6 limitations. It's a different implementation.
okay, maybe it's different implementation and so on. Tell me, Paula.
But to say that I'm using R, I don't need to use R. It's probably yes.
You have to declare. Maybe Python is implemented in another way that they need is learning by the data, but it's going to use different way.
Yeah.
It's going to say equal to or less than.
Yeah, if you say that,
Okay.
okay, this variable has to be greater than 2.9 and less than 3.01. It's almost the same thing as saying equal to 3, right?
No, because it cannot be the middle.
What do you cannot do?
If it's categorical, it cannot be 3.1.
No, I'm saying that's like, even if it's categorical, instead of saying this variable has to be equal to 3, you can say that this variable has to be greater than 2.9 and less than 3.01. What's the difference? Makes no difference.
Okay, probably they are implemented in a different way. So what does mean that one is okay? So that one so can be covered. What she did.
No, yeah, there is no way to go there anything else. That thing's part. There is no way to do anything different. How to bike it, yeah, how to bike it.
Okay, so maybe.
So you're right.
So it just means that some of the basins are really very correlated with high vegetation.
Yeah.
And that's it. And I think
That's
that,
what the data is showing.
that makes sense.
Okay, you know what you can do it due to the categorical shuffle. You can change it.
Yeah.
Or adding a random number
Check if
and
it's still,
Yeah, shuffling. but-
Shuffling.
Yeah.
okay.
I mean, change the ID
Mhm.
and rerun.
Yeah, that's it.
So
Just show the classes, right? Like
within the column, in the table.
Yeah.
Okay.
I would say you would get the same. It is a categorical variable and it is the most important. In categorical, the only explanation I find is that vegetation is just one of them. That's why they're so important.
Yeah, I think there are a few small basins that are
And
really
if you
important.
change the ID,
It wouldn't matter, does it? No, it doesn't matter.
Yeah.
Because it's still some
Yeah.
few basins that are highly vegetated.
Okay, try. I'm cool.
Or create a problem, another regular variable, which will the others try to suggest.
I also took away the basin variable and I run it again, and then the accumulation turned out as the most important.
Yeah, accumulation, yes, there is a.
And
because
then
it's
elevation.
accumulation of Water,
Yeah.
it's accumulating water down into the
Yeah.
river. So of course you have more water.
Yeah,
more water.
and then elevation went
And the
more
flat
down in
area,
the,
the same, flat area, the same. Probably.
yeah, but elevation was not so important anymore.
Okay, yeah,
So-
flow accumulation is really big in the water. Okay, good.